Hello everyone. In this video, we will discuss about the basic of Etabs for the beginners. Being a beginner, how you can start the Etab program with the modeling and analysis that we will discuss here in this video. So let me open the Etab program. It's taking quite time since the software is huge. Now go to File, click on the new model. Here we have three options to select. The first one is use saved user default setting, which means you already have done some project. From that you can import the preference like units and then properties like component sizes, beam sizes and slab sizes, all that, and then load combination, and then the code preference, that and all you can select from this setting. The second one is use setting from a model, which means by clicking here you can direct it to click some model which is already done. From that it will take the inputs of the basic like units and then preferences, all that it take from that model, or else you can go to use built-in section setting with, in which you can select the preferred units and then codes. For me, I am selecting metric SI units, and then still section database I select Indian. Still design code, here these are all the options to select. I select here IS 800 2007, and then concrete design code. These are all the options to select. Since I am designing for Indian code IS 456, I click here. If you want to select for American code or British code, you can select accordingly. I click on IS 456 2000. Now click on OK. Here this is a grid system. If you are modeling the structure with a grid system, you can go this option. The first one is uniform grid spacing, which means the grids in the x direction and y direction and the space respect in the respective directions. I am modeling with the grid system for the beginners. So let me take 3 grids in the x direction and 3 grids in the y direction. So I put here 3 in x and 3 in y, and then the spacing I put the uniform spacing. Here we cannot give the different spacing here. If you want to give different spacing, then there is another method is that I will explain later. Here I go for 3.5 in each grid in the x direction and 6 meter each in the y direction. Here number of story I go for ground plus 1. So number of stories is 2. The typical story height 3 meter and bottom story height is 3 meter. And then click OK. So the grid has been defined here. Now save this model in the desired location. I save this model in the desktop. I click Etabs. I give a file name of G+1 model and then save. So the model has been saved in the desktop with the name of G+1 model. Now let's start one by one. First we have to go for the define, in which select material properties. Here this is for the grade of steel and then grade of concrete we have to define. If you are going for the RCC member, then the grade of steel and the grade of concrete is the main parameters to define. So add a new material and then select code India, and then material type I select. These are all the options to select: steel, concrete, aluminum, cold form, rebar, tendon, masonry and other. So I go for concrete, and then standard I select Indian. I go with M25 grade. As per the size of the project, we can select the grade of concrete. I go for the M25 grade. Click on OK. So these all will be defined by the program. Click on OK here. And then now define the rebar. Add new material. Again, select instead of concrete here, select rebar to define the grade of steel. So here we have four options to select: mild grade 250, HOSD 415 and HOSD 500 and 550. So I go for HOSD 500 since HOSD 415 is not available and we are not using the mild steel for the reinforced structures now. Click on OK. So the grade of concrete and grade of steel has been defined here. Then click OK. Now go for section properties. The first one is frame section, which means the size of the beam and then the size of the column we can define here. These are all already defined by the program. You can delete it also. Now go to add new property. The beam is a rectangular section. So I click on the rectangle. I type here B. The size of the beam I go for 230 by 450. I type here B only for my reference, that indicating it's a beam. So I start with B and then material I go for concrete material M25. Then click here the depth of the beam. The section dimension is asking for the depth first, 450, and width is 230. Here property modifier. This is the property modifier which is used for the seismic analysis. For the beginners, I am not designing this structure with seismic forces. I go for only dead and live load combinations. So I don't modify here anything. Click OK. Reinforcement, modify here. Design type, I am designing the beam. So I am selecting the beam here and then the longitudinal bar grade of steel is HYSD 500 and the confinement bars are same HYSD 500, which means this is a longitudinal bar and then this is the shear bar and this is covered to longitudinal rebar group centroid, which means from the base of the beam to the center of the bar we have to calculate, which means say like your beam cover is 30 mm plus your ring size is 8 mm and then the longitudinal bar diameter is you are going for 16 mm, so you are using half of that 8 mm, which means 46 is coming. So this is the cover to longitudinal rebar group centroid, which means your clear cover plus ring plus half of the dia of the longitudinal bar, which gives the cover to longitudinal rebar group centroid. Here 46 is the value. 46 again here. Don't give any values here and click OK. Click OK. So I defined the beam property. While seeing here, I will be able to know that this section is for beam. That's why I marked this with B. And then again click on new material, add a new property. Here I am going to define the column. Column you can define either rectangle or circular or T section or I section. I go for the rectangular column. Here I type with C to indicate that this property is defined for the column to 30 by here the grade of concrete 25. Similarly, you have to define the larger dimension here in the column. So 230 is the breadth and the 450 is the depth. I type here the 450 larger dimension here and then 230 here, and then this I don't change anything here since I am not designing this structure for the lateral forces like seismic. Click OK. reinforcement setting. Here design type, I have to click here column and then select the grade of steel. This is a rectangular section. Here clear cover to clear cover for confinement bars. For the beam we have to enter the centroidal of the cover here, whereas for column we have to enter the clear cover. Nominally we take 40 mm to 50 mm, so it is already 40, so I don't change anything here. Then number of longitudinal bars along 3 directional faces, which means this is local axis direction 3 and 2. Along means along this way. About means perpendicular to this direction. So here it is mentioned as along. So 3 direction means along these faces we have given 3. So the 3 bar is showing here, and then number of longitudinal bars along 2 directional face. This is the 2 directional face. Along this face, if it is a 5, it will be indicating as 5. So in the larger direction it is mentioned as 5 bars, and the shorter direction it is mentioned as 3 bars. We can change it also to 2 bars or 4 bars here. Then here longitudinal bar size and area I am giving 20 mm. This for the basic input. According to the reinforcement required, you can give the required steel and with respect to the dia of the bar and the number of bar required. Corner bar sizes area I go for same 20 mm. Then confinement bar size and area is 10 mm I am giving. Click on OK. So now you see that the direction of 2 changed to 4 bars and direction of 3 changed to 2 bars. Click on OK. Click OK. Save the model. Now define the slab section. The second one is tendon section. If you are designing the structure with pre-stress or post-tensioning structures, you can go for tendon section. These are and all comes in the advanced level. So now I go for the slab section. Already there is a property of slab. I modify here, or I can modify here with respect to the slab thickness, selecting the grade of concrete, and then here we have to define membrane. The option has been selected as slab. You have variable options like drop, stiff, ribbed, waffle, matte, footing. I am defining this property for slab. So I click slab and then I write 125 as the slab thickness. Click on OK. You can add the property also, new property also, by clicking some different. I go for again 150 here. If you want to change internally with this property in terms of thickness, you can modify here, again change it, or you want to add additional property, you can go to add a new property and select your options and select your required thickness and then the property required. Click OK, and then reinforcing bar sizes. This is already as per the SI units, so I don't change any value. Now I am defining for the load pattern. Here it is already defined for dead load and live load. If you want to add some other load, external load like seismic load and then wind load, you can add it. For the beginners, I am designing only for the dead and live load cases. So I click OK, and then go to design, concrete, view your preference. Make sure you have selected your desired code, selected for the IS 456 2000. Then just only to cross check whether your desired code is selected or not. So it is already there, so I click OK and then go to load combination. Based on the code selected here, you can add the default load combination as per the codes. I go for concrete frame section, convert to user combinations, editable, click on OK. So these are the two combinations generated by default. The first one is 1.5 dead load as per IS 456. The second one is 1.5 dead load and 1.5 high load. I add one more combination for the serviceability. And 1.0 dead load plus 1.0 live load. Already dead is selected. I click live load and then click on OK and then click OK. Save this. Now we will start modeling. Before modeling, make sure that here this is selected for the all story, which means whatever you are doing in the one floor, that will be replicate to the all other above or below story. Or else if you are clicking here for one, so if you selected here for one story, whatever you are modeling, that will be reflect only in the one story which you selected. Select in the story 1, I select one story and add column and beam here. It will be reflect only in the story 1, not with the story 2. Whereas if you click here all stories, whatever you are adding here on the story 2, the story 1 also will be added the same column, beam and slab, whatever you are making changes or whatever you are doing additionally here. I select all stories and then click quick draw using this tool. Using this tool, quick draw column and then selecting the property here. I already defined column C230 by 450 and then I add here 1, 2, 3, 4, 5, 6. For the location, I planned the column and then now I define for the beam here. Click on this option, draw beam or column or brace. Click here and then select property of beam 230 by 450. Click here to here and then to complete this one, either you can right click or you can click here to here and then click enter. Click here and then click here and then right click and then click here and then here. If it is continuous beam, then you can click in the supports. Click here the beam resting from this column to this column and then from this column to this column. So these are all I have done in the story 2, the same which is created in the story 1. Now add a secondary beam here to make the slab sizes smaller. Click from this grid to this grid as a secondary beam and then click from here to here and then right click. So this is the slab, 4 slab and then 6 column, and these are all the beam location. Now I go for the draw floor, which means drawing the slab. Click here the property slab 125. This 125 as given for the preliminary design according to the span of the slab, shorter and longer span, and then the loading condition, the slab thickness can vary. You can check, you can calculate the slab thickness, and then you can add the respective thickness here. So according to the span and the loading condition, this 125 will be sufficient to this model. So I am adding 125 thickness here. I click the first point and then second point, third point, and then fourth point. Here similarly either you can right click or click on enter, and then same like the first slab, click all the four corners and then right click. Here also click. Now the column, beam and the slab has been modeled. This is the 3D image. Select basement. Since we selected all story, so the basement also created some slab. You can delete this basement slab. Now check the 3D model. Selected all story and then deleted. That's why the slab in the all story has been deleted. Undo this and then go to one story. Then select the base slab only. Then delete it here and then check. This is the ground floor slab, which means ground floor roof slab, and then this is the first floor roof slab. Plan view. There is one thing to be noticed, that when you are selecting like this, here the joint should be 1. If it is joint 2 or more, all these 2 beam and then column is not intersected properly. So you can reshape it to the position. Say like if the column and beam is not in the center of the point, if you are selecting like this, the joint is showing 2 here. This one frame is the column frame has been selected. If I select here, there is a 2 frame, which means the beam. So what you can do, you can reshape it to the center of the point and check it now. So the joint is 1, which means all 3 is connected in one point. That is the proper way of modeling. And then now we will apply loads, considering the wall load in the external area, and there is no load, no partition load here, and the story height is 3 meter. So what I am doing, 3 meter, and I am considering minimum of 450 mm depth beam, directing the 250 mm thickness of depth of the beam. So the clear height of the wall coming 2.55 into thickness of the wall is 230 I am considering. So 0.23 meter into density I am considering 20 for the brick wall. Here the load to be applied of 11.73. So I am applying the external only as 11.73. Assign loads, select distributed, and then 11.73. Okay. I applied only this floor as 11.73. Here only we need to apply the parapet wall, because here there is no more floor is there and there is no wall as well. So in this area, I apply only parapet load of 1.2 meter height So 1.2 into 0.23 into 20, which means 5.52 to be applied as a parapet load, parapet wall load. Click OK. The support condition is by default taking as pinned. We can change it to fixed by selecting the base story. Click on the base story. OK, and then select only one story. Select all these 6 points and then assign joint. Go to restraints. Here there are the option. This is the for the fixed support, which means restrained against all three directional forces and rotational moment, and this is for the pinned, which means all three directional force it will be restrained and the moment it will not restrain. And this is a you can either customize also as per the restraints you are giving. Typically we select the column for the fixed condition, so I selected fixed and then apply. Now you see the indication is changed it from this to this. Click OK. Go to design, select design combinations. It is already collapse cases, which means 1.5 dead load and then 1.5 dead load and 1.5 live load. Click on OK and then go to analysis, check the model. Select everything here and then click OK to check whether any errors are there in the model. Model has been checked, no warning messages were generated. So it seems, so it means it is okay. Again, now I forgot to add the floor loads, so I add the floor load now. I am applying 1.5 as the floor finish load. Since the thickness of the slab load will be taken by the program, which means the self height will be taken by the program, and the additional load, which means the floor finish load, I am giving here. Similarly on the above floors also as 1.5, and then high load I am applying for 2 kN per meter square, and then here for the terrace I am applying 1.5 as per the code IS 875. Now, so the floor load and then the wall load and then the parapet load has been applied. So whatever the load has to be considered in the model has been taken. Now click here for run analysis. Model has been analyzed and click design concrete frame. So the pink color indicates that the column is passing for the given loading condition with the given size of the column. The area is record of 3195 mm square. You can provide the reinforcement accordingly. Let's see check the percentage of reinforcement. Coming 3.09, 3.23, 3.23, 3.09, and then below story is coming 0.84, 1.17 and 0.84, and then here 0.84. Since the building is mirror from this point to here, this point to here, these reinforcement and these reinforcement should be the same for the dead and live load combinations, and this is mirror to this area. In plan I will show you how this portion is mirror to this portion, so reinforcement required here should be the same at here. And since the reinforcement is coming 3%, which is quite little bit high, we normally go for, as per the code it says that we can go for up to 4% of reinforcement from the cross sectional area, but in practical we give not more than 3%. So I revise the cross section of the column by increasing its sizes. I tell you how, like again I am going to sectional property, frame section. I defined here through 230 by 450. I am modifying the section property here. I go for 600 instead of 450. I make changes of 600 here. After changing to 600, the size of the column has been increased. Again, run analysis. Design. Now check the percentage of reinforcement required. Now from 3102 it is reduced to 2400, which means the size increased is impacting in the required reinforcement. Now it is required of 1.76, 1.48 and 1.76. This is the required percentage of the rebar. So for the 230 by 600, the column sizes and the reinforcement is satisfying. Then beam reinforcement we will check. For the 230 by 450, the maximum percentage of reinforcement is showing at the support, since here the moment value will be higher and moment at the bottom will be higher here, so it is showing 0.89. Let me check with the AST. Here we are required of 824 mm square and 206 mm square in the middle and 824 mm square in the top and the bottom of 921 mm square. Let me check the beam bending moment diagram for the dead and live combination. So this is the bending moment diagram reflecting same as per the loading condition. So here there is a negative moment and here this is a positive moment and this is the negative moment at support, and this is a simply supported, continuous simply supported, which is resting on this beam and this beam and this beam. So here there is a negative moment in the middle support. So this bending moment diagram looks okay. Section, click OK. So how we can provide the AST in the column means, here there is a record of 2433 on all 4 columns that you can go for with a 20 mm dia. 2433 divided by 314 it is coming 7.75. So all these 4 column you can provide 8 number of 20 mm dia which will be sufficient, and then here it is required of 2041. So 2041 divided by 314 is the area of the 20 mm dia, which is coming 6.5. So here also you can provide 8 bar of 20 mm dia, and beam reinforcement you can provide. Here we need to provide 30%, 25% to 30% as a through reinforcement, and here you can provide support as extra reinforcement. From this reinforcement, how we can give the beam detail based on SP34, that I will explain now. So this is code SP34. This code is dedicated for detailing based on the design result, how we can give the structural detailing, that we can refer by using this code book. So whatever the maximum reinforcement is coming, either at here or at here, from that 20% through reinforcement we have to give at the top, and considering this span is L1, and from this to this continuous beam is L2. After 20%, the remaining percentage of AST to be given as 100% till 0.15 and 60% up to 0.25L, which means 20% we have to provide from the maximum reinforcement as a through reinforcement, and then the remaining which is coming at here as 60% up to 0.25L, and then the 100% reinforcement to be given at from the face of the column to the 0.15 of this L1 span, and then the bottom reinforcement up to 30% we have to give as a through reinforcement from the maximum, either maximum span of L1 or L2, and the bottom minimum 30% of through reinforcement has to given from either L1 or L2, whichever coming more, and then from 0.1 L1 we can omit and we can provide the 100% reinforcement from the face of 0.1 L1. Similarly at here, whatever the maximum reinforcement coming at L2, we can omit 0.15, and from 0.15 L2 we can give the 100% reinforcement, which means 30% as a through reinforcement. The remaining with the respective span how much it is coming, that we can provide as a 100% reinforcement from the face of 0.15 L2. So our AST is coming in the beam. Here at this first beam we have 824 mm square at the top and 206 mm square in the middle. This is at the middle, and similarly this 412 is coming support bottom, and 921 is coming middle bottom. Based on this result we can provide a minimum reinforcement of 216 through, which means 400 mm square as a through reinforcement, and we can provide 3 numbers of 16 mm dia as a extra reinforcement, which means you are providing at support 5 numbers of 16 mm dia, which gives 1005 mm square, which is more than 824 mm square. And at the bottom 412 is at the support and 921 mm square at the middle at the bottom. So I am planning for through reinforcement of 3T20, which means 3 numbers of 20 mm dia, 3 into 314. I am providing 942 mm square of through reinforcement. And the same result is here, so we can follow the same number of bar and the dia of the bar at here, and at this span the top support is coming maximum of 1268. So at the middle top it is required of 740. I am planning here at 2 bars of through reinforcement at 20 mm dia and 3 bars of, which means 314 into 2 is 628, and then at support I am providing extra reinforcement of 3 bars of 20 mm dia, which means at support totally 5 bars of 20 mm dia, which gives 1570, which is more than the required. Similarly at here 520 is the total number of bar, which means 3 numbers of, sorry, 2 numbers of 20 mm dia and 3 numbers of 20 mm extra we are providing as a curtailed reinforcement. And at the bottom we can go for the maximum reinforcement is coming 1621 mm square at the middle, and bottom support it is record of 634. So I'm planning of 320 is a through reinforcement, 3 numbers of 314. 941 we are providing from this phase to this phase, and 320 extra reinforcement. From 0.15 L we are ignoring and then providing the 100% reinforcement as per this code. Sorry, it should be like 0.1 L1, not 0.15. We can omit 0.1 L here and here, and then we can provide 100% reinforcement here. So totally we are providing 3 bars as a through reinforcement, 3 bars as a curtailed reinforcement, like this 3 bar is a 20 mm dia and this 3 bar is the curtailed reinforcement. Totally 6 numbers of 20 mm dia, 6 into 314 coming 1884, whereas our record is 1621. So we are providing more than the required, hence it is safe. With this beam we can provide 2 section of through reinforcement, as it is record of only 147 mm square at the middle top, and 588 is the support extra we need to provide. So we can provide 2 section of through reinforcement at the top and 1 section of extra reinforcement at the support top, and the bottom we can provide 2 section of through reinforcement, which is satisfying 2 into 314, 2 into 201, which is 402, which can be satisfied on both these beams. Similarly the same reinforcement to be followed at here, and this secondary beam we can go for here the maximum coming at the support. Since here it is considering as a support, we have a negative moment at here, so it is required of 714 mm square at the top. So we can plan 2 numbers of 16 mm at the top, which means 400 mm square at the top through, and there is a balance of 300 mm square that we can provide 2 numbers of 16 mm. So place at the support we are providing of 4 numbers of 16 mm dia, which is coming 804 mm square, which is more than required. And at the bottom we are providing 2 numbers of 16 mm as a through reinforcement, and the maximum bottom is coming 586. So the balance of 186 we can provide 116 extra 0.1 from this phase to this phase. Similarly at here extra reinforcement of 116. So the bottom through reinforcement is 216 and extra curtailed bar is 116. This is how we can prepare the reinforcement. For more such videos, please subscribe my channel. I'll be trying to post more relevant videos like this. Thank you for watching. Bye bye.